what is Mina aiming to play in the broader ecosystem?
Mina Protocol, the most popular thing that you hear is the world's lightest blockchain. And that's made possible because of recursive zero-knowledge proofs.
As blockchains grow and become more abstract and also complex to understand, mathematically dense, is there any risk of power being concentrated in the hands of the very people like you who understand them at a deep level as a designer or as the mathematician or the cryptographer behind it?
You use like a known language to be able to write applications. On the protocol layer, I think we need to ensure protocol decisions shouldn't require cryptographic expertise.
And what are the risks involved in it in comparison to other blockchains?
The risks.
Hi, I'm Dr. Lorena Nessi for CCN, and today I'm joined by Deepthi Kumar, co-CEO of o1Labs, the co-development team behind Mina Protocol. We will discuss Mina constant-size blockchain architecture, the role of zero-knowledge proofs at the protocol level, and how stability affects decentralization and the broader implications for verification. Hello, Deepthi. Very nice to see you here at CCN. Welcome.
Thank you so much for having me here, Lorena. Excited to delve into this.
Yes, well, shall we start from the very beginning with some background and general knowledge about what's the role of Mina Protocol? You know, what is Mina aiming to play in the broader ecosystem?
Yeah, so I guess a bit about myself. I joined in o1Labs in 2018 as a protocol engineer. I'm one of the early engineers who worked on Mina Protocol, and ever since been part of like the project in various roles and capacities. Mina Protocol is the most popular thing that you hear is the world's lightest blockchain. And that's made possible because of recursive zero-knowledge proofs, where we recursively compose proofs about a block, and at the end of the chain, you get one proof that verifies the entire chain. So anyone who wants to verify the entire blockchain state, starting from Genesis, you verify that one proof that you get at the latest block. So this architecture is made possible because of the zero-knowledge cryptography. And one of the biggest impact of Mina and its architecture is the ability to build privacy-preserving applications. If you look at traditional blockchain systems, there are smart contracts that are fully public and get executed on chain. Every single node is executing the smart contracts. However, in Mina's architecture, you have something called zkApps, which is zero-knowledge applications, where the application itself is executed off-chain, but verified on-chain. And this, again, is made possible because of snarks. So when you execute it off-chain, you generate a proof, and then you submit that proof to the chain that verifies that that proof is valid, which means that whatever the computation was, that's correct. So you don't have to actually execute the program. So that's sort of how Mina is different from a lot of other blockchains, and it really enables you to build like privacy preserving application, preserving user data, and not putting it on chain.
Brilliant. So zero-knowledge systems actually rely on these advanced cryptographic proofs that you're telling us about, rather than replaying the full transaction histories, right? And that's what makes Mina probably not simpler, but probably more lighter. Is that correct?
Yes.
How
Yeah.
should users actually evaluate or should evaluate correctness and security when these verifications become more abstract and math driven, relying
Yeah.
on cryptography?
Yeah. I mean, there's I think there are various levels of abstraction, and where one needs to like scrutinize or focus on the like I think the most important thing is it's a different sort of paradigm. So when you're building applications, you're kind of writing you know at the end of the day, you're writing zero knowledge like circuits that gets boiled down to lower level like cryptographic operations, like elliptic curve operations. But you abstract that away to a point where it is intuitive for users to build applications. For example, like o1JS, which is a SDK that we use on Mina to write zero knowledge applications, is built on TypeScript. So when developers write programs, they're writing in a language that they know. They have experience writing like web applications, and so that sort of abstraction layer is important. So you can kind of you avoid leaking implementation details, all of that to the users, right? But at the end of the day, if you go at the lowermost level of the system, there is that core cryptography proof system, and that's where there is sort of that expertise required. You need to ensure that proof systems, they're open source, they're well audited. You're always like staying on, cutting edge research and engineering and development to make sure like you incorporate all of the new developments into your proof system. So I think that's I would say like different layers of the system where you have like various ways to mitigate. It's not perfect. I think there are still a lot of things that we could do. One thing that kind of jumps out is we still don't have that standardization in the zk space. There are different proof systems, there are different SDKs, different languages. So that sort of fragmentation it takes away, I guess, as focus or scrutiny that maybe one system could get. But I think it also allows for innovation. You can try different things, and soon a few will emerge to be the standard. And I think the ultimate goal is for people to trust these systems. Like, for example, how we trust TLS. Like, you see HTTPS and you're like, okay, this is secure, right? So you want to reach that level, and there is still a bit to get there.
Okay, brilliant. So we are talking about these different systems, about the importance of maths, about the importance of the design of the system as well, which is in hands of the cryptographers. So as blockchains grow and become more abstract and also complex to understand, mathematically dense, is there any risk of power being concentrated in the hands of the very people like you who understand them at a deep level as a designer or as the mathematician or the cryptographer behind it?
Yes and no, I guess. I think, yes, complexity, always risks sort of centralization of understanding. So you want to try and I think again it does come down to like different layers of abstraction. There are like some mitigations that I mentioned, like you use like a known language to be able to write applications. I mentioned o1JS. There are also zkVMs where people can write programs in Rust, which then to build zero knowledge applications. So that way, like, you don't need specialized skills to like write these programs, like general software engineers, software developers, or who have learned these different general purpose languages are still able to like build, right? So at the application layer, you don't want you want to make sure as many developers are able to like build these applications. That is important for adoption. However, like, on the protocol layer, I think we need to ensure protocol decisions shouldn't require cryptographic expertise. Like, users in the system shouldn't have a cryptographic degree or experience to be able to like participate. The community should be able to weigh in on economic policies, ecosystem priorities, even if they cannot audit like the circuits themselves. It is important for them to participate. So it's really important to separate kind of those layers, and the implementation details shouldn't kind of leak. I think, and standardization again is another thing that you mentioned. So as each best approaches emerge, like you can start, the implementations will become mature, and so you will start building like tooling around those standards that make it less and less dependent on the expertise, right? Cryptographic expertise.
So, as a user, if most users cannot have a complete copy of the chain themselves, if they can no longer verify the entire chain, even if that chain remains small, how does work this idea of trustlessness? What does that mean in simple terms?
Yeah, I mean, I think there might be like a slight negative connotation when you say trustlessness, but what we really mean is that when you say trustlessness, everyone doesn't need to do everything in order to have trust in how the system works, right? Like in traditional, like in the blockchain design itself, the decentralization, any distributed system requires each participant to compute, and especially in blockchains, everyone is duplicating the same computation on their machines, to not have to like trust anyone else. Like, I am doing the computation and I'm verifying. But I think it's not. So trustlessness shouldn't be that everyone does everything. It rather means that there's no like privileged verifier, or verification is inaccessible. Like, people should be able to participate if they want to. So, but not every participant will run a validator node, right? They might just want to get the network state at some point. So the question is, like, can they independently get that state, or do they rely on, institutions or individuals that serve them that data? So I think that's sort of how I think trustlessness, or what trustlessness means in this setting.
And what are the risks involved in it in comparison to other blockchains?
The risks, I think the ideals of blockchain is to be able to not rely on central parties. So you want to, if you're building a decentralized application, you want to get the data directly from the chain, and not have to depend on other central actors. And so if you do, then you are bound to the benefits as well as challenges of the central institutions. I do not want to just call out the challenges, but there's always also some benefits. But the goal is to build decentralized systems in the space, and so that's with that goal. I think you want to try and make it as easy and as efficient for people to achieve that.
Okay, brilliant. Now going on to the other side of these ideas of the discourse, we know that early blockchain design has assumed that storage and computation costs are going to continue to fall indefinitely. Is that the case, you think? Does Mina Protocol bring something different into this landscape? Are there assumptions about scalability that we haven't taken into account?
So scalability isn't just TPS, right? I think it's also about decentralization, who can independently participate. If you scale the system to just increase the TPS and make the nodes themselves like quite compute intense, then you require like really sophisticated hardware and systems to run it. So if so that it requires focusing, balancing a few different factors. TPS, of course, is one thing, but you also need to be able to balance the decentralization aspect. Who can verify? The industry is kind of building faster systems, but they're ultimately getting more centralized because of these like really high requirements on running nodes. And so it becomes the true scalability challenge is to create a decentralized system which is long term, sustainable, where node operators can continue participating, new participants can join in without having to require a city's worth of compute. And then, but at the same time, you kind of have to balance the need for user experience, reduce latency, and all of these properties that make such systems really usable, right? So yeah, I think it's a very difficult sort of balance, but it scalability isn't just TPS. There are these other factors.
If you had to put it in very simple terms, what do you think are the main, let's say, three aims that Mina Protocol is trying to achieve in comparison to other systems?
First and foremost, making it extremely easy for people to participate in the network, whether that's running a node, which means we have very reasonable spec. You can run it on your laptop. We're also in the process of implement or building a web node, so you could run a validator node on your browser, so it's easy access. So that's on the protocol layer. If you want to build applications, you can use o1.js, which is like a TypeScript library to implement. So it's again easy access to even build applications. So I think that's really the for us one of the most important things. And secondly, it is this notion of like privacy preserving applications. We want to be able to like build applications where user can protect their own data. They only need to verify what is required. If it is age, I will verify my age, but I don't have to give you my entire my entire credentials, my whole ID, my everything. If you want me to show that my balance is above a certain value, I can prove that to you without having to give you my entire credit history so you know my spending. So I think we really want to be able to enable building such applications where user data remains with them, but at the same time be able to prove compliance, be able to prove what is needed for them to participate in the world.
Great. Changing a little bit the topic before we wrap it up. I am interested in your role also as a woman in a field that is normally male dominated, especially at the senior technical level, as an engineer who makes all of these protocols and develops these systems. So in practical terms, what challenges have you faced, especially in establishing this technical authority or in influencing the protocol decisions?
Yeah, this is always tricky, I guess. So I joined o1Labs in 2018 as one of the first engineers. So my influence has been built through long-term technical contribution. I've been kind of fortunate to work in an environment where decisions are driven by engineering rigor, and respect, and not hierarchy or identity. In fact, o1Labs was listed in top 10 Web3 companies to work for. I can share the link later on, but I just want to kind of emphasize the culture that we have. It really brings out the best, I guess, in people. But this is probably isn't like representative, experience for rest of the crypto industry. I've heard difficult stories from peers. I've seen, if things happen on X, and I've seen, biases in other organizations, exclusion, harassment. So my advice is, I think it really is to choose environment carefully. We need to build range in our craft and not really internalize the broken system and call it out when it needs to be called out. And I think at some level, like in we're building a decentralized system, we need to like take account for decentralized viewpoints. In fact, it's homogeneous teams often miss out on or certain threat models, like user perspectives. Like it's always in software engineering it's better to have like diverse perspectives. So
great, thank you. And to finish our interview, how do you see the future of cryptography and blockchain look like?
Looking at all of the news that you have, a lot of traditional finance is starting to realize the benefits and are ramping up to use blockchains. So for example, real world assets on chain, that's the advancements that are happening there. It's really cool to see. Governments adopting the identity solutions that blockchains provide. That's like amazing to see, because it really shows the scale at which like blockchain systems can operate. And especially in using like the zk technology, where we can use the zk technology to prove your identity. So I think this we're slowly starting to like the use cases that are most impactful are starting to emerge. There's still a lot of I think there's still a lot more we can do with zk. And yeah, I guess it's as the proof systems, or as the systems get more efficient, and as you're able to run on consumer applications, consumer devices, I think that's when the adoption will really start like picking up. So I think in the zk space, there is probably still bit more to get there to be able to like efficiently prove on my phone, on my laptop, like applications. But I think it's moving in sort of that direction.
Thank you, Deepthi. Is there anything else that you would like to add?
Yeah, for Mina, I think we're definitely continuing on this journey, like making zk. Making a splash in the privacy space. We want to continue enabling this, building the system that enables like building privacy preserving applications, and our efforts are always continuing towards that.
Brilliant. Thank you so much, Deepthi, for joining us today at CCN. Thank you.
Thank you so much, Lorena, for having me. It was fun talking to you.